Hello and welcome to the next part of my Unity tutorial series on making a third-person action platforming character. What's a majiggy mathingy mabob? And so here we are in Unity. We've got, from the last tutorial, a little character that rotates to follow our direction. We can move them with the WSD or slightly more appropriately with the left mouse the left thumbstick of a controller. We can jump by pressing A or spacebar. One thing I noticed whenever I was messing around with values and settings and different stuff is that whenever I jump onto the side of this box, my character just gets stuck. And that's because of friction. It's because of the simulated friction in the game. It's not working properly the way we want it to, right? We want our character to slide down the side of our box, but because we're constantly putting our vector of our character moving sideways into the box, it's sort of getting stuck. So one of the ways we can do that is with physics material. Now, I can't remember if we set a physics material for our character in the previous tutorial, but what I'm going to do is I'm going to go ahead and make a new physics material. We can call this like no slide or something. And essentially what we have here is a bunch of different values that are by default are 0.6, 0.6 for our dynamic and static friction. And if we set both of these to 0 on our character, and then we also set we set these values to 0 on the actual physics material, and then we set that physics material to the collider on the character. So here's the character here. It's just called cylinder. I'm going to rename this player just for further reference. Here's the mesh collider physics material none. So I'm going to drag my physics material onto here. But it's not enough that I just do this to my character. I'm going to also have to do it to all of the other objects that have colliders, because otherwise it's going to be like half as much friction as it combines both the friction of the character and the friction of the object they're colliding into. So I'm going to go ahead and drag this into my cube, and for good measure, I'll stick it on the plane as well. Oh, I already did, but okay, here we go. So now hopefully my character will sort of slide down the side of my cube, so no more wall jumping, unless of course that's something you want in your game. Random Spider-Man action. For now, I'm going to want my character to slide down the side. And the other thing I noticed is my character's rotate reset isn't quite working the way I had intended it to. Oh look, our character is just kind of spinning around now in circles, and that's because I think I put the friction on the ground. Let's make that not the case. I'm going to turn the friction off on the ground, so I deleted the physics material. There we go. We're back to our character retaining the last rotation that they had. So you can have too much of a good thing. We don't want the physics material that would seem on the floor, or else our character will just kind of spin around in frictionless environment forever once we stop rotating it. Let's go to my character controller, which had a magnitude query of greater than 0 in the last video. If the magnitude was greater than 0, then we rotate. However, really, I only want to rotate if the magnitude of my turning direction is greater than a larger amount than 0. If my direction of the left thumbstick when I move to the left goes from 0, which is in the middle, to -1 on the very far right, or +1 on the very far left. No, the other way around. -1 on the left, yeah, and +1 on the right. Then for our magnitude, what we really want to do is check if the magnitude is greater than a certain value, which is, say, halfway between there, so 0.5. And that's basically, 0.5 is then the dead zone for our direction that we're rotating in. In this case, we only want to rotate once we've got our stick right at the edge, once we're pushing it right in and our magnitude is greater than 0.5. So now I'm going to run this and see if this solves our problem. But there's a potential another problem. So here we go. So whenever I move up and to the right, you can see I'm sort of getting a good deal out of this. But there's a problem, which is whenever I move in certain directions, my character still flicks off to the side. You can see it sort of happening sometimes there, like. And one of those problems is because of the way I'm handling my if statement, which is if my magnitude is greater than 0.5, because I've just realized that if the values of these are in the negative, for example, then my magnitude will be a negative value. If I'm going all the way to the left, which is -1, and all the way down, which is -1 on the y-axis, then my magnitude will potentially be a negative value. At least I think it is. I'm not quite sure. It returns the length of the vector, which might not work in the negatives. One thing that I can do just to put my mind at ease is instead of using the magnitude of both of the values, we can just use the x value itself and the y value. So we can check if the x value is greater than 0.5 or if the x value is less than 0.5. Right, because we want both extremes. Or, let's add another big set of ors, and I just duplicated ors for those, and we'll use another or for our y, and another or for our y again. Oh, I didn't do my negative. It's less than -1.5, and less than -1.5. So we've got every combination here. So we're gonna really rotate, basically, if our x rotation is particularly high or particularly low, and same with our y value. So again, just another way of doing things. I'm not sure which one is better, which one will work. Maybe this will be more smooth and I'll have less flickering whenever I move my thumb off the left stick. I don't know, but ultimately some things to experiment with there. I'm going to move on though, because I could really be here all day with this rotation, and instead I'm going to move on to some camera stuff. So I'm going to use a special package that is part of Unity by default these days, which is called Cinemachine. Cinemachine is a really smart tool and a package for setting up camera angles, camera transitions, cutscenes, all that kind of stuff, and we're going to use it for our third-person camera controller, though we're going to have to do some code to expand the functionality a little bit. So I'm going to go to my package manager, and this is opened on my other screen, so I'm going to drag this back across, and this is what you'll see from your package manager. I'm going to go ahead and search for Cinemachine, so I'm just going to start by typing in CINE. Now make sure all packages is selected here, because if you select in project, it will only show you all your current packages, whereas we want a package that we haven't got yet, which is Cinemachine, and I'm just going to go ahead and click install here, and it will now import all of the assets and scripts and preset stuff that we need for Cinemachine to function. And while this is loading in, I'll just explain how it works. Cinemachine essentially has two different parts. It has a brain. What's called a brain, it's just a script, but it's a Cinemachine brain that we're going to attach to our current camera that we have. And then we're going to have virtual cameras, which we'll set up which can be selected for where the camera is. So that means we can set up lots of different virtual cameras potentially, and then have our actual camera swap between using those virtual cameras. However, in the game at the moment, with like cutscenes and stuff, we just want one camera. So we're going to start setting this up. The first thing I'm going to want to do is add a brain. So I'm going to type in brain, and there I can see Cinemachine brain is one of the things I can add. So I'm going to go ahead and add this component to the object with our camera. And now you can see this little symbol has appeared here next to our camera, and it's got a Cinemachine brain, but the brain doesn't have any virtual cameras to use yet. So I'm going to go ahead and create a new empty, and this one I'm going to call vcam1 for virtual camera 1. And I'm going to go and add a component which will be a virtual Cinemachine virtual camera. So now wherever I move my virtual camera at the moment, because there's only one virtual camera, our current camera will lock itself to that virtual camera. And the really handy thing about this is it's just set up quite automatically. So let's say I have two cameras. I have camera 1 and camera 2, and I put them in two different positions. Like I move this one slightly off. Oh dear, this rotation is going to get a bit funky. Maybe I'll first reset the X rotation, then it'll be easier to rotate it on the Y axis and then tilt it down. There we go. So if I go ahead and turn off camera 1, because camera 2 is the only camera that exists, it will now lock the actual camera, and you can see here in the game preview, it will lock it to camera 2. But if I turn off camera 2 and turn on camera 1, you'll see it will swap to camera 1. So this means that all we have to do is set up all of our virtual cameras and turn them on and off in code, and we can change where the camera what the camera looks at, and there's other things we can do as well. For now, I'm going to go ahead and delete these cameras, which were just to show, and I'm going to make a new one, which is going to be, again, our empty, and it's going to be our free look camera. And our free look camera, I'm going to go ahead and add a free look camera, Cinemachine free look component to it. Now, this kind of camera is something that's we're going to be able to rotate around our target. So there's a whole bunch of different values here, but the most important one are these two, the follow and the look at, which are looking for transforms. So we can go ahead and drag our player into the follow and the player into our look at as well, and immediately we can see we're very up close and personal with our character, as the camera will automatically set itself near our character, so that whenever we move around, it will follow the character and it will also look at the character. And look, you can see as we move around now, our character is following, and we've got this automatic movement as well of the camera around with our mouse and with our right stick as well. Okay, not with the right stick actually, just with our mouse for a moment, but we'll have to code the right stick then. So yeah, this is kind of looking good, but it's zoomed in far too far in. So what I'm going to go ahead and do is where I have these top rig, middle rig, and bottom rig, these will set the values of where my camera, how close my camera is to the character and what height it's at. And you can see this with gizmos turned on in the scene view, these little red rings for the top, the middle, and the bottom. So I'm going to go ahead and look at my top ring and see what values can I change here. These are actually more advanced values, but these are the values I'm looking for here. So top rig, height and radius, middle rig, height and radius, bottom rig, height and radius. So the radius is going to basically be how far the camera zooms out. So let's go ahead and increase the radius of the middle ring, and you can see it's going to zoom way out. Now it's very imbalanced compared to the others, so I'm going to go ahead and make my bottom ring a bit wider. We still probably want our rings to be, the top ring and the bottom ring to be smaller than the middle one, and that's so that whenever we move our camera down, it starts to tilt up, so that you can look up, and whenever you move your camera up, it tilts down so you can look down, and that's usually the behavior of a third-person camera. So I'm going to make this radius a bit larger here, and now we can kind of see the relative heights. So now whenever we move our camera around the character, we're still very zoomed in here, aren't we? But we can have a little bit of a better view of our character. I'm just going to make these values even higher than before, so we're probably going to double them, so this could be 18. That looks a lot better. Now one thing that you may notice is that now that my radiuses are so large, the height maybe needs to change as well. So change the height of the top view and the bottom view. So make them much larger. Let's run the game now and see. This is probably a lot better value for how far zoomed out we should be from our player character. But we're not really able to go look up above the character or look down very much. And that's because of our relative height to the character. So let's go ahead and make a change. The first thing we're going to do is we're actually going to bring the radius of our bottom rig in a bit more and lower it. So its height is 0.4. Let's lower that to 0.2. And maybe we'll have a better angle looking up at the character now. A little bit better. Again, how extreme you want this angle to be is going to depend on your design. So as with all programmy things, feel free to fiddle about. And to get a top angle, I think this one will want to be more extreme for our particular game, because we're going to do platforms. We might want to really be looking down at our character. So I'm going to make the height of this go way up from what it was before. And now hopefully we'll get a better angle on the character when we zoom up. Again, to get a higher angle, we might even reduce the radius of this a bit more. So when we look up at the character, there we go, we can zoom way down. So yeah, just fiddle about with these. You might want the radius to come down, you might want the height to go even further up. It's all a case of design here for what we really want. I'm kind of happy with these values of looking up and down. So now what we need to do is apply this rotation to our character, because at the moment, if I rotate the camera around and then start moving, like by pressing W on my keyboard, you can see that the camera is following my character, but the movement is not relative to where my camera is looking. So really, that's not what I'm looking for at all. So instead, what I'm going to go ahead and do here is I'm going to try to work out how to apply my current camera position relative to the character to the movement of the character. So to apply something, that usually means multiplying it by a certain value. In this case, how are we going to get that value? Well, the first thing we're going to want to do is get the vector of our camera. So I'm going to go ahead and do that here, and I'm going to get that as a vector 3. So I'm going to get a vector 3, which is going to be equal to I'm going to call it cam forward, let's say. And this is going to be equal to something, and I can get this from the static class camera. So I can get camera.main, which is going to get our main camera. Then I'm going to get the transform of that camera. And then finally, there's this value forward that we used before when we were rotating our own character, if you remember. So this is going to get the forward position, the forward direction as a vector 3 of what our character is looking, the direction our camera is looking. So now that we've got our camera forward, how do we sort of multiply our input by this value? Well, before we do anything else, I'm going to think about the angle that my camera is in relative to my movement. I don't really want to apply a downward movement whenever I'm looking down at the character, or an upward movement when I'm looking up, because we've already got a jumping to handle that kind of thing. Instead, we want to flatten essentially our camera's perspective onto the ground and then apply that on my X and Z values, on my X and Z axes, but not on the Y. So then I'm just going to go ahead and flatten this by setting this Y value to 0. So the Y value of my camera forward is 0 because we don't want to use that when we multiply our relative motion. There's one last thing we want to do. We want to turn our vector 3 into a quaternion. So at the moment it's a vector 3, which is usually used for movement. So I'm going to turn this into a camera rotation quaternion, which is going to be equal to our camera forward. And how do we turn this into a quaternion? Well, I'm going to go ahead and do quaternion dot look rotation. And what this is going to do is it's going to create a rotation with a specific forward and upwards directions. We can leave the upward direction blank and just use this forward direction, because then it will assume that up is up, and in our case we're not doing any strange gravity where gravity is sideways or something. So that's going to be fine for us. We've got our camera rotation now, which is going to be flattened as well, because remember we flattened it by setting our Y to 0. So now that we've finally got a quaternion, what can we do with this quaternion? Well, we can multiply our input by this quaternion. And I'm probably going to want to do it before I clamp the input. Now we've got a problem. Our vector 3 is a clamped input. Our clamped input is a vector 2 because it's got an X and a Y. But we want to multiply it by our vector 3. So there's a couple of different ways we could do this. We could turn either the input into a vector 3 or the rotation into a vector 2. For now, I'm just going to turn this into a vector 3 to start with. So I'm going to do clamped input is equal to vector new vector 3. So I'm changing this from vector 2 to vector 3. And then for our Y value, we'll just set this to 0. And now that we've got it as a vector 3, we can multiply our clamped input. So it's multiply equals. And we're going to go ahead and use our new camera rotation to multiply our clamped input by this value. Okay, it doesn't like this. Why doesn't it like this? Is it because I'm using the wrong thing? Let me try and work this out. So we've got our clamped input is going to be equal to our clamped input multiplied by rotation. Cannot be applied to vector 3 and quaternion. What have I done wrong? Let me try and work this out. So clamped input is a vector 3. We're going to set it to be equal to itself, which is clamped input, multiplied by our quaternion. What if I do it the other way around? Is that the problem? Okay. That's very strange. I don't remember why that is the case, but in this case, we're taking... I know why it is. We need to multiply the quaternion by the vector, not the vector by the quaternion. Surely that's the same thing. Very strange. I'm not sure why the C# has a problem with me doing it one way and not the other, because whenever you multiply two values, you should just get the same result. I'm not sure what's going on there. But ultimately, okay, by swapping them around, it somehow it doesn't complain at us anymore. I can try and work that out later. We've got our quaternion, which is the direction of the camera that we flattened, and we're going to multiply that by our input. And then we're just going to clamp it as we did before, turn that back into the move, and use the move later to actually move the character. So let's see. Moment of truth. Let's see if this works. So now whenever I hold left on the character movement, our character just moves forward, and they move back and forth along this line. What's gone wrong? Something's gone wrong. Oh, is the problem that we're using our Y? We're getting our Y from our Y. I think that's the problem. Strangely enough, now that we've turned it into a vector 3, our movement isn't along the Y-axis, because remember in 3D, Y is up and down, whereas in 2D, Y is sort of is up and down on a flat plane. Yeah, it's getting a bit confusing, isn't it? But ultimately, we need to take the Z value of our clamped input, because the clamped input is now a vector 3. But we're using vector 3 clamp magnitude here as well. So maybe that's going to be a problem. Let's see. Clamped input is a vector 3. Yeah, so we'd better use vector 3 clamped input, clamped magnitude as well. We're just doing vector 3 everything. So we change this here, clamp magnitude, and we also are taking the Y-axis for our Z-axis for our Y movement as well. So hopefully this will work now. Let's find out. So now whenever I hold left, our character moves left relative to our camera. When I hold right, they move right and back and forth as well. Hooray! All right, I think I still haven't quite got the hang of this flicking motion, right? Whenever I move the character, they're still very sort of jittery and with the rotation. So I've definitely not fixed our problem with this nonsense code that I thought might fix the problem. But oh well, maybe you can try and solve the problem yourself. At least now we have got our camera working, and we've got our relative movement. And the interesting thing about our relative movement, the fun thing is, because we're just taking the camera perspective, whatever direction the camera is facing, and multiplying our movement by that direction, we can have any kind of camera we want, and the rotation should still work. So like, I'm not going to delete this so that I can still turn it back on later, but I'm going to turn off my free look camera for my third person movement. And let's say I went ahead and did a cinema machine, and I did a let's see, what kind of thing that I want, a state driven camera. and then I had a state-driven camera, and I just set the same values to player follow and player look. And then let's see, can I set a value for how close this should be? Let's get rid of one of these. Let's get rid of one of those values anyway, because the point isn't, what is the camera. I can try and work that out for later, different camera setups. But if we move this camera out and we rotate it to face the player, any camera angle, right? Now our character should still be moving relative to this new camera angle. So whenever I press right on my stick, I'm moving to the right, left on my stick, moving to the left, all relative to my particular camera angle. All right, that's going to be now for this tutorial. I did get a little bit stuck in the middle there with some complicated Quaternion rotation. I still have this thing to fix, so perhaps I should just use the magnitude. If magnitude is greater than 0.5, that looked better. Another thing I could check is what if the magnitude is less than a certain value. So I could say if the magnitude is less than 0.5, minus 0.5, that's good enough as well. I could run that and see if that helps with any of my problems. Does my character flick less now? Oh, this is looking promising. Maybe this was the magic bullet. So what I was thinking there is that if I have my stick down all the way to the left, right, and that would be like a large negative value, then that would be a value less than minus 0.5, if that's how magnitude works. So this is our final version here, which is hopefully going to give us less flicking, but it's still a work in progress. But I think I've at least got it to as good as it was before. We've got our movement jumping, which is going to slide off our rocks. I'm going to turn off this state-driven camera and turn on our free look. And there are a whole bunch of different cameras, angles, and perspectives that you can use for your movement. I think the last thing I want to do, and this will just be for those of you who are using controller, the last thing I want to do is add controller movement to the camera as well. All right, let's have a look at how to do that. Now, do I do that in code or do I do that? Let's see. I think I do that in code. Here I've got mouse Y and mouse X, which are the input axis names of the controls for our movement, which at the moment are, mouse Y and mouse X. So what we're going to do is add inputs for moving it with the controller as well, so that our input, which is on the right stick, which I think is horizontal and vertical, will also work. So to do that, I'm going to go ahead and go to my project settings. And now I can select from these various different options our input. And I can see that from my right stick, I have a couple of different values I can use. I've got mouse X and mouse Y on mouse movement and mouse movement X and Y, which is currently controlling it. So I'm going to go ahead to the size of my axes and set this to 20. And now I've got two new axes that I can use for my right stick. I'm going to call them the same things. I'm actually just going to be a bit sneaky here and call them mouse X and see if this works, and mouse Y, because they're the same names, this will take input from both of them. They are in fact going to be axes, joystick axes, instead of buttons, so I'll change that on both of them as well. In fact, I'm mostly just going to copy all of the values that I have from this horizontal and vertical, these versions here, because these are the left stick axes, right? So it's going to be like a gravity of 0, a dead zone of 0.19, a sensitivity of 1. So dead zone of 1, 9, a sensitivity of 1, and a dead gravity of 0. I'm going to get rid of this, get rid of this, get rid of this, get rid of this. So I'm just setting these up as axes. And this is going to pull in the axes from our right stick. So whenever I go to the axes, it's not going to be our x-axis. It's actually going to be our third axis and our fourth axis, which is the right stick up and down and the right stick left and right. I might need to invert these values. I'm not sure yet. At the moment, yeah, I can go up and down by moving my right joystick left and right. And I also can rotate with my left and right trigger. So I think that actually maybe it's the fourth and fifth. Let's try that. Or maybe it's the fifth and sixth. Yep, so at the moment I can look down at my character with the stick, I can move up, and I can look left and right. And you'll just sort of have to take my word for it that I'm using my right stick to rotate the camera now. And the values are potentially inverted, but it's easy enough for me to change that because I can invert the value here for that particular input. Some people actually play there with their controllers inverted. It's a very kind of old school thing, a legacy from old games like Halo 1 on the original Xbox that had inverted controls by default, and GoldenEye and stuff. Anyway, so this is a way of setting up your, if you have a controller, to set up your right stick so that it will feed in. The reason I called this mouse X and mouse Y is just so that I could keep the mouse movement as well. It was a very sort of lazy way of doing things. Otherwise I could rename these to right stick X and right stick Y, and then I could rename these as well. But then only the controller would work, not the cursor. So I'm just going to do that for now because I'm an incredibly lazy person. Alright, that's going to be the tutorial for now. Hopefully it's given you some ideas as well, not just for a third-person character controller with this very specific setup, but also if you had a camera that was doing something else funky, like a different cinema machine camera that is following things around, or just a regular camera that you have static in the air, or one that's being moved by code. Any of these things are going to work well with the relative movement that we have now to the camera. Alright, I'll see you in the next tutorial. Good luck.